while the others are having fun with cycles in the theater, I'd like to introduce you with a software named BlenderVR. So my point here is to propose a piece of software that works and to have as much, not critics per se, but as much comments from the Blender community, because it's a tool we do not want to stay in a closet forever. We want it to be more or less available for every one of you who are working with the Blender game engine and would like to see something else than, I designed a nice piece of thing in the Blender and then I switched to Unity, or then I switched to Unreal to have virtual reality. So we wanted to have a whole pipeline based on Blender and the Blender game engine. So as it's a piece of software, I'll just go through what its objective is and what's the point, what are our main goals here, and then just will update you a bit on what's the project state today and what we hope it will be tomorrow. So 4 years ago, the point was, so my chief arrived in the office and told us that we needed a way to use for our virtual reality architectures nice assets from whatever 3D community. So we went through the softwares and soon grasped that more or less two solutions were available. Or take one of the Unity, for example, based plugin, VR, and pay for it, but have something ready to use. Or we actually saw that Blender game engine was quite efficient, even if you had some time to tweak scenes a bit to have the assets ready. But we finally just decided to make it a proof of concept. So our main objective from the start was that any student or any repository from the internet providing a new scene should be plugged and play in any architecture we had. So no redesign of the scene to play in a cave or in a head-mounted display. Maybe redesigning the gameplay, because of course it's not the same. Things like the heads user displays cannot be positioned the same. But the point was, yeah, to have a one-to-rule-them-all architecture, to be able to have scenes portable in whatever architecture we wanted to. So the basic recipe with BlenderVR is that you've got actually a scene that you just grasp from the internet or you develop on your laptop. And to that, you add the definition of your architecture, the screen's position, how many users do you have, all the things that are dependent and that define your virtual reality architecture. What kind of nodes do you have? Which are the addresses you want to play with? And all that you just blend into the BlenderVR GUI. And the point of the old software was to be able to simply add a new scene, press play, add a new scene, press play. So I'll just go through the features for you to get a better understanding of it. Basic example. So directly render any Blender scene in my architecture. So as I was not at the time a good game developer, I just went to Martin's repository and downloaded a random scene. Just to show that, or at least make sure that it would work the same in my architecture. So here I'm downloading it, and on the left side you can see that I just opened it in BlenderVR and started. So what you'll see appearing here is the tiny console that allows me to just check that it's working. But what makes sense in this demonstration is what happens on the right side of the video. So if you may please, right. So this is the basic principle. It's in a cave here, but the whole goal of the software was to be able to grab the scene, plug it, and then conserve the logic of the scene through the demo. So once we had this first piece of software that seemed to work nicely, the next point was to be sure that every nice and cool feature from the game engine was still there in the architecture. We wanted to keep the animations, the physics, all the controls that make the game engine so appealing as a game software development. Here you can see a weird guy playing with actually physics. You can see that there is a synchronization between the screens rendered by different computers, that still there is a logic that's conserved behind the object. You've got animations. So this was the second step of the project. Once we had something that was plug and play, make sure that all the features of the game were respected to synchronize between the slaves and master, because you have to have some kind of master node that says the cube here has been just hit by another cube, and not every single computer on its own deciding whether or not the physics just happened. So we had this, and the next step was so one user on one architecture is nice. Of course, when you're talking about virtual reality, you just want 1,000 users in the same scene playing with the objects with their own point of view. So same way, in the configuration file, we just had to tweak it a bit to make sure that every single user would have his own points of view and be able to interact with the scene. So in that video, you can see that the image is a bit blurry, but for each user, you've got the two rendering stereoscopic position with the two Susans you can see on the screen. So it's basically just doubling the framework of the initial BlenderVR, making sure that each user has its own position rendered through its own node, or if you've got shutter glasses, at the correct position in time. So we had that feature, and of course, since a cave is not the most popular VR architecture in the world, the next step was to make sure that people with simple, like head-mounted displays, for example, could use the software. So there's, of course, the plug-and-playness with a simple Oculus Rift or other displays, but our point here was just to make sure that if I've got two laptops, can I still play at two users in the same scenes? And again, just assuming that we redefine the user's position, which is in the core code, meaning the end users do not have to play with, it works straight out of the box, assuming you add another monkey to mimic the position of your friend's head. So this is simply to say that as long as you define the architecture, who is the master, who is the node, the slave, and you define who is which monkey in the scene, or you don't have to have a monkey, but where am I? Where is my keyboard? What is my keyboard? Is it a joystick? Or so I just go through the features and we'll list all the tools already implemented and what we plan in the future. That particularly interested me. So as a basic, I'm a sound engineer, and that's always the first thing you notice when you go in VR architecture is that they have huge fundings for VR displays, for tracking systems, and often they just forget that if you add sound to a scene, it just makes it more real. You can see on the Blender animation without the sound, it doesn't make any sense at all. So my point here was to, the same way we use BlenderVR as a simple wrap-up around the Blender game engine, meaning that it's a simple piece of software that doesn't implement anything than this master's, whatever, synchronization definition of the architecture, and that will eventually evolve with the Blender game engine. Because we are not that much developer on the project, we wanted to make sure that the core software wouldn't need our help to be improved. So the same way that this worked with the Blender player and would evolve along with the Blender player, here we designed something based in MaximSP that you heard on the previous talk. MaximSP, which is a sound software and which already has and will have in the next years really powerful rendering engine for sound, ambisonic, binaural, wave field synthesis. So you've got a bunch of techniques, rendering techniques, that allow you, once you simply have the position of the 3D object and the size of the room, which kind of material do you have in the room, the acoustic of it, to simply have the scene visually, but also in the audio domain. So without the sound, it's not obvious. You'll see in the final video what I mean, but basically you've got a bunch of tools around MaximSP that allow you to have, once the objects are tracked and using the OSC protocol sent to MaximSP, have the whole auditory scene made out of the scene you just grasped from the internet. Just saying with the BlenderVR API, this is my cube and it goes meh, this is my sphere and it goes bear. So where are we now? Same way that Blender did, being able to diffuse your software is making sure that you've got a proper installation or no installation at all. a proper way for users to help or to use without helping, a way for people to complain, because it's really important to be sure that they can complain if they want, even if it's free. So first step was to have a bunch of tools for install, being able to fetch the sources, to modify them. The website first, with all the news on the software, the basic tutorials, video tutorials, the assets to grab, like core basic scenes. The user manual, of course, for BlenderVR users to be able to, okay, what happens if I want to play with my DK2, or if I want to use a VRPN protocol, if I want to use these kind of scenes in these kind of architectures. So simply to list all the features, same way, always through read the docs, the API, just to be able to use the short method we did in BlenderVR to, for example, have the user position, not the user in Blender, but the real user position through the tracking system. Or how do I say this cube goes mo with the OSC protocol. So without having to touch anything of the protocol, you just say BlenderVR dot send this thing goes mo. And finally, of course, the GitHub account that already allowed a bunch of users to help us with the developments, the API, and the features they wanted to. So today, the available assets, this step-by-step installation guide, because as for today, we still need to install it because it needs its own Python. It does need its own Python, but Blender doesn't have all the Python methods one needs. It needs a complete Python, so either you have one or it guides you through the installation of it. A detailed documentation, just to know what is the pipeline to play with a rift and a cave, or 2 rifts, or 500 rifts, or whatever video wall displays, and how to use example implementation, you know, this kind of tiny Blender file that just explains, this is how you do this. So core implementation for users to be able to grab the asset, play with it, improve it, or just add the different bricks of VR architecture design. How to use video tutorials, of course, and this sound rendering engine I talked about, which is simply a wrapper, again, around MaximSP patent tools. So that way, both tools will just evolve on their own. And because the main community using Blender for today is Windows users, we first targeted a Windows 7 installer. It works on all platforms, but that way you just have a simple exe file that you today can open, double-click, and install on your architecture. As for the latest developments, so basically how it worked, this whole creation pipeline, we designed it for a first architecture. It worked fine. Then we searched for someone else needing the software, and eventually found another architecture which forced us to rethink the whole concept of, yes, but there must be some kind of offset for the user's position because they won't always be at 000. So this is one of the last architecture, the 3D Mesa understand 3D table. And so it's kind of a cave, but just with one display on a table. And so this was in Visgraph Lab in Brazil, and one of our partners, so Dalai Filinto, went there and just, okay, so this is the new configuration. Does it fit what we already have? And so that's how we work, more or less. Every single time we meet a new architecture, we just try to integrate it and make it resilient regarding all architecture we would like to. The next development was really quite interesting. That was all about cheap case. I just have a single projector at home, and I wanted to be able to project not on a single wall exactly in front of my projector, but on a corner, or say on 3 different walls at the corner of my room. So here the whole point was to actually, same than the configuration thing I talked previously, just define my room. So the images you see on the right side here, just define my room in the virtual environment, and then use a kind of camera frustum. So here it's square, but you could imagine whatever shape you want. And actually use this camera frustum to move in the virtual scene and render the viewpoint of each camera on the screen in my room. So that way it would apply on the screen of the computer, you can see here, a pre-deformation that would just anticipate the position of the projector respect to the screens. So here we also use the tracking system that goes with BlenderVR. So that simply says, please put my camera position where I actually stand. And that's offer you actually tracked position. So here you get the glasses that we use for the positioning. So just for the coders in the room, if any. So the project, of course, went through developments and addition in the Blender core code. And thanks to the Blender developers, actually, some of these features were actually implemented in the core code, such as all these tiny features, the pre-draw setup callback, for example, which just allows to avoid always moving the camera to be able to see a different position. Because when you got 5 different users interacting in the same scene, you can't afford to have 5 different cameras. It's always easier to grab the scene from the internet that has one camera fixed on, say, a flying carpet, and then use this kind of method. Same goes with the get stereo eye. This kind of method that just allow you to say, this is the current master viewpoint, so this is my current viewpoint, and these are my 2 eyes viewpoint. And the last feature of these 3 I selected from the GitHub is the lens shift, which was so far implemented as a rendering in Blender Render and Cycles, but not in the game engine, which simply allows you to use a projector which lens shift is not in the middle of it. Because if you want to project things on a display which is at less than a meter from the projector, you want the projector to be able to be or on the floor or on the ceiling to avoid having it at the real middle. So that was just the coding part of it, just to note that the project actually brings new assets to the code. This is one of the projects I'm most exciting about. So it recently came that a California lab just asked us if BlenderVR could adapt to these kind of architectures. So do imagine a cerebro-like sphere of projectors all around. And so there is nothing square in this kind of architecture. So you do imagine that there is some kind of change we would have to make to the code. But this is one of the next projects we have in mind to make sure that BlenderVR works on this kind of architecture with a bunch of computers working on Linux, OS X, Windows, and all interconnected together to render a single scene where user can move, evolve, and play with. This is one of my personal projects, which is so sound. Be able to reproduce a real concert in a cathedral where you would have actually the real sound in the cathedral based on your position, the instrument's position. So there is a whole pipeline based on render the different impulse responses from sources to receivers. Then when you move, you actually use the convolution between. But the whole point here is that based on this BlenderVR plus Blender Game Engine plus MaxMSP, it's all just about tweaking the main components to actually have this kind of scene. So it's now that the software is pretty stable, we do want to do some kind of example of how to use it to its best to make some, let it say, advertising for the software. Thanks to the latest developments, now the Python API allows you to access physical components. Where did I hit the object in the scene? What was the normal to the collision point? And we do want, of course, when you talk about VR, we do want to implement haptic in BlenderVR. So again, not for a specific device, but just for all kind of virtual reality haptic inputs through VRPN, for example, be able to actually perceive the reality of the scene, both as a feedback and as an input in the scene. So that's one of the projects we're currently handling to Intense, just to see if they make it work. Intense in our lab. So again, it's never really funded. It's just based on who is interested about, okay, so you'll take the asset and you'll try to develop it. Future development also involve body tracking, of course, to be able to have people dancing in the cave, or simply based on have your avatar in the real world. A work that Dalai, Filinto, and Benoit Toulsay also did for the render which is the DK2 rendering based on frame buffer object, which allows for those of you who know that the direct mode thing. There was a whole discussion about the direct mode and all. So this is one of the features I haven't been in touch with recently, but basically make it resilient with the next generation of head-mounted displays. And that already works for the render part of Blender, and they actually ported it. Dalai actually ported it 2 days ago to BlenderVR code. And the scene you can see here is a scene that Martin, she's actually currently developing for. I said that every scene could be ported in BlenderVR, but we had a few interesting talks yesterday who said that you can't expect an animation to work at 1 secs or 2 secs, whatever. You can't expect a game which was not created for a VR application to be really using all the features of a VR application. So Martin, she's actually working with me and Dalai to, okay, he is working on his own, but we were trying to help, to make something that would use to its best the features of BlenderVR, mostly of the Blender game engine in BlenderVR, with the sound that goes with it, both in terms of gameplay and luminosity, animation, and all, for any kind of architectures. Of course, HMDs in case, but also the Elosphere you saw a while ago. And I've got still a bit more time, so I'll just enjoy that to show you the demo reel we did. Simply to, again, do some kind of show, just to show people before they went through the painstaking, which was a painstaking process of installation, which is no longer, just to show them what they could actually eventually dream of once they did it. Ooh, that won't do if I do not have the. I'll just take a few seconds. My brother went through a lot of pain to create that sound, so I just want to make full. These features should definitely exist. Okay, no spoil.
Have you seen a light before? Have you knocked on the door? Have you only called my name until this time of shame? Did you ever look at her? I should know I stand for hours. Yes, I know I'm just too proud to only take the blame. I'm feeling kind of safe. I'm liking this Monday.
One of our first projects, but it was the same in the cave, with only 2 via walls and stereoscopic rendering. The Mesa 3D.
Now won't you start to play another game? The story must unfold as we begin to fall.
This is a basic example of how to use VRPN, which is one of the tutorial demo I talked about. Another one using the WeBalance board, also on VRPN.
I can see you clear within the
I'm really proud of that scene though.
I will never save myself from you. I will never save the life from you.
The story must unfold as we begin to fall.
I will never save myself from you. I will never save the world from you.
person falls as we begin to fall.
Thank you. Yeah, I do have, and I do bring a DK2 with me if you want to test it. Mm-hmm. You want to do it on Blender? So yeah, that was the all. Do you actually? I just repeated what is already available online. But do go on, and I would be most pleased to. We are still at the phase of the project where we have more critiques and comments where it could be constructive to help us test new applications. I'm definitely willing to. It's BlenderVR. Yup. I should remember it by heart. This kind of thing you never... Okay, so that's the main website.
So what kind of a machine are you running on?
Am I?
For DK2 development?
Both Windows. I'm developing on Mac. Both Windows.
If you're developing on a Mac, you'll pretty much work on anything because you have a Mac Pro or you are just an iMac or something.
Exactly. That one of machine, so it's not that powerful in terms of graphics.
Yeah.
And
Sorry, can I disconnect you? Can I disconnect you?
you're Martin. It's an honor. Thanks a lot for your work. You know that you were the main reason why we didn't stick to Unity. My chief just told me, you know, Blender is crap. You won't do anything with it. And I just showed him the 2 or 3 scenes you had at the time on your repository. I never considered.
So, okay, so this presentation is about how to create customized bracelets. We have produced them in silver and also in gold. This is the first one was gold and this is silver. So if you like, you can come to me after the talk and just inspect them and feel them. It's very smooth, the quality is very high. This is it was produced by Shapeways, and I will also give you some to get a feeling for the letters, because this talk is about the letters, the form of the letters. So, what have we done? We have built a tool that can be used to create customized bracelets. So everybody, even those who are not able to create models or are familiar with Blender or 3D in general, are able to create customized bracelets. And my company, which I have founded a couple of years ago with some friends, are in general doing 3D product configurators. So this application about that I will talk today is just one of many applications that we are running. So we are creating commercial models, commercial business models with Blender as core. And without Blender, it would not be possible for us to fund the company. And so we are very thankful that Blender exists, and we say thank you to the developers every day. When I wake up, I thank the developers of Blender. So what are we doing? You see some applications here. Whenever a producer or a reseller sells products or produces products that can be customized in some way, for example, you can change the color or the material, or you can combine several components of the products, then it's very hard to show the user the end product, because you have so many variants and combinations. So it is not possible to make a photo of each of those combinations and show it to the customer, but the customer must see the final product, because otherwise he or she will not sell it. So it's very important to visualize. And what we do with Blender is we visualize the final product, and this is also what we have done with the bracelet configurator here. So okay, the shop for which we have done this application is evolvinguartdesign.com. It is an international shop that sells individual jewelry, necklaces, bracelets, and so on. Everything is very individual made according to the requirements of the user. And now the shop has another application, and this is the customizer for bracelets. And I have just recorded a screencast yesterday evening, because the internet is kind of shaky here. So this is the shop itself, and this is the application. And you only have one single input line, and in this line you just type in your letters. Whatever letters you want, you just type it in, and then the rendering result is shown directly on the web page to the customer. You have different viewing angles, and finally you can also choose different diameters of the wrist joint, because not everybody has the same size of the wrist. If you choose smaller ones, then there is less place for the letters, so the application must somehow consider this. And you can also choose gold as material, which is also then simulated and visualized in the application in the web shop. And it was very important that this application is very easy to use and integrates seamlessly into the web shop, because otherwise it would not be possible to create a business model around it. I have a question. Yes, of course. You visualize this with Blender, web for Blender? Actually, we do not use any special plugin or so. It's very, very simple, and I will come to this on the next slide. Okay, I will come to this, I think, in 2 slides after this one. Let's have a look to the process that was necessary before we integrated Blender into the process. At first, the shop owner has to create interest to the customer, of course. If the customer is then interested, the customer tells the shop owner which letters he or she wants, which size is a wrist joint, and then the shop owner has to sketch the bracelets, the individually created bracelet. This sketch is then sent back to the customer gives some feedback, the sketch is reworked and so on, and after 3 or 4 iterations the customer is happy. Then a modeler is hired. The modeler then models the bracelet, and again, after rendering it, it's was sent to the customer to give feedback, and the customer gives have some remarks, and after 3 or 4 iterations the customer was happy, and then it could be produced and delivered. So, and this process took about 2 to 4 weeks, so it was a very long process because of the many iterations and the many manual work that was required. And now with Blender, we just skipped the steps that were very time consuming. So of course, the first step is, again, you have to create interest. So the customer must come to the web page. The customer types the letters, as you have seen in the screencast, and it's immediately visualized. So all the iterations are just happening inside the brain of the customer. After some different variants, the customer is happy, and then it can be produced and delivered. So what took weeks is now done within minutes, and this also is only possible because of Blender. Blender is used very heavily here in the pipeline. The application that you have seen is part of the web shop. That means it must integrate seamlessly into the web shop, so you don't have to use any complicated plugins or so. It must also run in the web browser because the web shop actually is running in the web browser. You should not depend on any hardware because that would reduce the number of users that can use such an application. And of course, it must have high usability because we want to sell products. And if the customer is not understanding how that application is operated, then he will never or she will never buy anything. And this brings me to the problem that if we tell the customer here, you can use Blender and create your own bracelet, and then it won't work because Blender is not a tool that you can learn within minutes. As you know, you need your time, so it was very important to do something to emphasize or to make it more usable. And finally, the application also must make sure that any bracelet that is customized by the user is also can be produced at the end. And this is done in the application. So now to the architecture, you asked me if we use any plugins or so. Actually, it's very, very simple. You have on the right side the shop, and the shop is just a web browser where the web browser has served to the shop. So either it's running on the desktop or tablet or smartphone. And all those data that is typed in from the customer is sent to our render farm here on the left, and the render farm just produces the pictures. That's all. So there's nothing complicated or plugin or hardware required. This is very simple, and it must be so simple because it must integrate seamlessly to any kind of web page. And we just integrate an image that is rendered just in time the customer is sitting in front of the application. Okay, I would like to talk about the departments that are involved in producing such an application. And we have the web front end, of course. We have also the modeling part and the shading part and the 3D printing part. And these are my next slides. And for modeling, it's very important to meet the printing criteria. For example, we are using shapeways, so we have a minimal technical width that we must meet. We cannot print below this width of 2.3 millimeter for silver and gold. We also have to make sure that the number of letters are not too few or too many on a specific diameter. And we also have to make sure that all letters that we send to shapeways are also printable. And unfortunately, the Latin alphabet was not invented with the vision of 3D printing. And for this reason, if you try to print the I with its dot, it's just an epic fail, because if you print the I, the dot just falls apart and disappears. So we have to make sure that this never happens. And there are so many letters, especially in the German alphabet, which gives us a headache. but we somehow cope with this. Gold versions, and this actually is they print it in bags, and then they fill it with plaster. This is some kind of how to say a material that has a very low melting point, and to create a net negative of the model, and then they